Okay, I'm going to talk about angles and radian measure. An angle has an initial side and a terminal side. If the initial side is the positive x-axis and the vertex of the angle is at the origin, on a coordinate plane, here's the origin. When we measure the angle counterclockwise, we have a positive angle. This angle in particular measures 135 degrees. This other angle is also said to be in standard position, meaning the vertex is at the origin, so this is the origin, 0, 0, and this is the positive x-axis or the positive horizontal axis. When we measure the angle clockwise, counterclockwise, this angle in particular measures 260 degrees, positive. However, if we measure clockwise, we have a negative angle. This angle measures negative 100 degrees. Angles, these two angles that have the same terminal side, when it's in standard position, they are said to be coterminal. So we're going to find a few coterminal angles here. We could have the angle that starts here negatively, and that would be, well, 360 degrees is the entire circumference, so that minus 135, that would be negative 225 degrees. If we could have this other angle, start here at the initial side, go towards the terminal side, and go one full time around and end at the terminal side. Well, that would be 135 degrees plus another 360. That's 495 degrees. That is also an angle coterminal with 135. This angle is also coterminal with 135, and this would be, take the 135 and go twice more around. We could go 3 times more around and find another coterminal angle, and that would be 3 times 360 degrees plus 135 degrees, 1,215 degrees. All these are coterminal with 135 and with each other. In general, to find coterminal angles, we take one of the angles and add a multiple of 360 degrees, because that's a full circumference. N has to be an integer, positive or negative, but an integer. All right, that's general angles. Now I'm going to talk a little bit about arc length. What is the arc length? Recall from geometry that the arc length is the distance on a circumference of an arc. So let's say we have this circumference here with radius r and central angle. We're measuring this arc that goes from A to B. The central angle is theta. So we want the measure of the arc that goes from A to B. And let's say theta degrees is 80 degrees, and the radius of the circumference is 9 centimeters. So the arc length is simply part of the circumference, the proportional part of whatever the angle is over 360 degrees. So the arc length is the angle over 360 degrees times the entire circumference, which is 2 pi r. So in our particular case, that would be substituting theta for 80 and 360, well, we have that, and the radius for 9 centimeters. So we have that, well, the 0 can cancel the 0. 9 times 2 is 18, and 18 and 36, well, that is, 18 is half of 36, so this becomes a 1, this becomes a 1, and this 36 becomes a 2. So we have 8 over 2, the degrees cancel, pi centimeters. 8 over 2 is 4, so 4 pi centimeters. That's how much this arc measures, 4 pi centimeters. Now 4 pi is a little bit more than 12, almost 12 and a half. So we have that the arc length divided by the radius is the angle. If we divide, arc length divided by radius is to be said the angle in radian measure. Radians is another way to measure angles, and it uses a proportion. If we divide the arc length by the radius, we get the central angle, in this case in radian measure. Arc length, we usually write it with an L. So the arc length can also be said to be the angle in radian measure times the radius. Got the formula right here. Length equals angle in radians times the radius. So in particular, if we have an angle that measures half a radian and the radius is 14, the arc length is very easy to get. We just multiply length, arc length is angle, 0.5 radians, times 14 centimeters, and that's 7 centimeters. Notice that I don't put radians here because radians is just a ratio. Arc length, it's units of length. Radius is units of length, so it's just a ratio. The units of length cancel. So that's 7 centimeters. If we have an arc length, radian measure of 0.25 pi, an angle of 0.25 pi radians, and the radius is 40 millimeters, then the arc length is the angle, 0.25 pi times 40 millimeters. Well, that turns out to be 10 pi millimeters, which is about 31.4 millimeters. So what's the relationship between radian measure and degrees? Well, if we take an entire circumference that measures 2 pi r, but we can think of the circumference as an entire arc. So the radian measure of the angle of a circumference, it would be the arc length, 2 pi r, divided by the radius, r. So radius cancels. We've got 2 pi radians. However, we know that an entire circumference has 360 degrees. So our relationship is that 2 pi radians is 360 degrees. If we divide both sides by 2, we get the pi radians. Usually we just write rad for radians. Is divided by 2, 180 degrees. So sometimes you're going to get asked to transform degrees to radians or radians to degrees. For example, here we got 60 degrees. How much is that in radians? Well, we multiply it by 1. Notice pi radians is 180 degrees. So this is a 1. The degrees cancel. So we got 60 divided by 180 times pi radians. Now, 60 and 180, put it in lowest terms, it's 1 and 3. So we got 1/3 pi radians. That's equivalent to 60 degrees. Something similar here. We have an angle of negative 200 degrees. We want to pass it to radians. We multiply times pi radians over 180. The degrees cancel. 200 divided by 180 is 10/9. Well, this is negative, so negative 10/9 pi radians. When you can pass this to a decimal, this is about 1.047 radians. And this one is about 3.491. Negative 3.491. Okay. Usually we will want the exact value, so we use pi. Now if we have an angle that measures pi over 6 radians, we want to pass it to degrees, Well, we take the reciprocal of this ratio. 180 degrees is pi radians. We have it here. So we have that the radians cancel. And 180 divided by 6 is 30. Pi and pi cancel. So that's 30 degrees. If we have an angle of 10 radians, notice no pi. So that would be multiplied times 180 degrees over pi radians. And 110 times 180 is 1,800. Pi, the radians cancel. And we have an angle of 1,800 over pi degrees, which is about 572.96 degrees.